Okay, this is called slope-intercept form. Slope-intercept form. Usually the name of these forms are based on the information needed to use it. So in this particular case, M represents the slope. Okay, I don't know why they choose letter M, but letter M it is. M is slope. Just a quick reminder here, slope is the change in y values over the change in x. Okay, and B is the y-intercept. Okay, so that's a point 0, comma B. All right. So we're going to graph. Y equals 2/3 x minus 4. Okay, that's what we're going to graph. Now, in order to graph a line, you need a starting point and you need a slope. So you can count rise over run. So the starting point, now I'm not going to call it y-intercept, I'm just going to call it a point. If you plug in 0, 2/3 times 0, 0, minus 4. Okay, so there's my starting point. Any point will do. So you're going to put that point on the graph. Okay. And then your slope is 2/3. That is rise over run. And it's positive. That means these are both positive. Plus 2, plus 3. So 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Now you can count in both directions. You can count to the left too. Just make sure -2, -3, because two negatives make a positive. And connect. Okay, so you got little straight edges so that you can make it really neat. All right. Whew. Okay. Number 2. Okay, let's try y minus y1 equals m x minus x1. Okay, this one is called point slope. Why do I call it point slope? Because I have a point. Look at the slope thing. I have one point, x1, y1, and I have a slope. Those are the two things I need to graph this equation. Okay, so this is called point slope form. All right, in this particular case, m is still the slope. I'm not gonna, okay. Sometimes we see slope as change in y over change in x. Still just the difference, right? Rise over run. And in this one, our point, okay, our point is x1, comma, y1. Now I'm going to put these two graphs on the same grid. Okay, if you want, you could use a different grid. I'm trying to conserve a little bit, so it's up to you. Mine's pretty open here. So here we go. Equation. I'll just put it over here. Y minus 3 equals negative 3 parentheses x plus 4. Okay. I'm going to do one thing here. I kind of like to see my equations in y equals format, so I'm just going to add 3 to both sides. Okay? This is the format, but I like to see y by itself when I'm trying to graph. So I'm going to scooch this 3 over to the other side. Don't simplify. Leave it just like that. Okay. Now I want you to pick out what's the slope, what's the point, right? Because I need 2 things to graph a line. I need a slope and I need a point. Well, slope is pretty reasonable. I'm actually going to write down the point first because where do you start your line? You start your line at a point. All right. This looks kind of interesting. I have a parentheses with x, and I have this number on the outside. Left 4, up 3. It's actually transformations. Point slope form is actually transformations. Left 4, up 3. Okay, look at my format. See how the negative is built in? That means it's opposite. So this is left 4. Okay, now remember I added this to the other side, up 3. So the x-coordinate is opposite. The y-coordinate is the same, just like in transformations. Okay, so I'm just going to make a little note. Left 4, up 3. That's my starting point. What's my slope? My slope is, and I'm going to write it, negative 3 over 1 so that I can see the rise and the run. When you have just a number, put it over 1 so you have a rise and a run. All right, put it on the graph. So I'm going to zoom out just a little bit. Okay, here we go. So negative 4, 3. 1, 2, 3, 4, 1, 2, 3. That's your starting point. You don't have to start at the y-axis. You can start anywhere on the graph. Okay, count your slope. Okay, this time it's negative. So rise over run. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Now really you only need 2 points to graph a line. I was just sort of counting across the grid to make it easier to draw the line. You can count to the left of your starting point also, whichever direction is easier. Okay, and connect. Okay. Okay. I guess I'll just make a note to myself. This is where I started. But you always start at the point and then count the slope. Yes.
I just read to y equals mx plus b.
You can.
I started at a different spot. Is that going to be considered wrong?
No, it's not. And the reason that I like point slope form is what if your y-intercept isn't an integer? It gets kind of funky to try to graph from some fraction point. And that's why this one is a little bit more versatile. But no, you can do it. This just happened to work out nicely both ways. But no, there is no wrong way to graph a line. There's just some ways are easier than others. That's it. All right. Here we go. I'm going to flip my page, and I'm going to put 3 equations down. You graph them. So new grid, okay? New grid. If you want more than one graph square to graph, that's fine. I'll try to make them not overlap too much. Okay. Examples.
No, I'm just no. I'm just like you can use the one because that's like a question.
Okay. In just a minute, I'm going to ask for a volunteer to explain to me how you did it. I picked them on the outskirts of the lines on the graphs anyways. Okay, here we go. 1, 2, 3, 4 volunteers. You get to tell me one step. Number 1, what do you do first? Where do you put it? Okay. Okay, which is what? 1, 2, 3, 4, 5, 6. Okay. I saw a hand in the back. Is that Lex over there? What do you do next? Wait, hold on. Shh, I can't hear him. What do you do? Over 1, up 4. Okay. Be more go right or left, up or down. And then 1, 2, 3, 4. Okay, I'll take a third volunteer. What's another way to plot a point? Tell me what direction to count from my starting point. Yes. Yes. 1, 2, 3, 4. You might think I'm silly for asking that, but I've seen it messed up a whole bunch of times, okay? All right. And connect. Okay. Whoop. There we go. Okay, next. I'll take 3 volunteers. What do I do first for number 2? Somebody new. Come on. There's lots of choices. Yes. Say it again. Pick out the point. Perfect. What is the point? 8. Okay. This is a little tricky. You see how the 3 is not on the other side? So it is 8, but it's -3 because when I leave the 3 over here with the y, it's actually grouped up, and anytime it's in grouping symbols, it is opposite. So just be careful that when you want to do the transformation, it's got to be in that y equals format. Okay, so it's 8 -3. Perfect. 8 -3. Okie dokes. And next. Okay, yes.
You do the slope, you go up 1 to the left 3.
Oh, perfect. Love it. He said up 1 to the left 3. Okay. Here's my starting point. Okay. How else can I count the slope? Yes. Down 1, 3 to the right. Yes. Right. So you can go to the left or the right of that starting point. Just make sure that. Oh. Okay. So I'm going to count this slope a little bit better. Okay. So my line, I didn't draw it very straight, but notice how the y-intercept is nondescript. It's some fraction point. That's why this is a little bit better of a format, okay? Because I can't tell what the y-intercept was. Now my line isn't as neat as it should have been, so it should have been more like this, right? And I can't tell what my y-intercept is. There we go. Okay. It's another good reason to count your slopes a little bit further. There you go. I can't actually tell what my y-intercept is. All right. Okay. All right, I'm going to switch to pink. All right, last one. X equals 5. Y equals -6. Oh, those are the weird ones. Okay, try to plot a point, guys. Try to plot a point. Or 2, because you need 2 points to make a line. Try to plot a point. And when I'm looking at this, the only thing I can tell is that I have an x-coordinate of 5. X equals 5. And there is no way to find the y-coordinate, so it could actually be any number. So if x is always equal to 5, that's a vertical line. If x is always equal to a number, this particular case, 5, x is always equal to 5. It makes a vertical line. And the way I think about that is I try to come up with points. Right? I try to think of points that would fit into that equation. And the only thing I could come up with was x coordinates of 5. Okay, so I'm going to do the same thing for y equals -6. Okay, -6. The only thing I have here is the y coordinate of -6. That's the only thing this equation is telling me. Y is always equal to -6. Doesn't matter what the x is. There's no way to find it. So -6 is a horizontal like the horizon. So it's straight across. This is our horizontal line. Okay, so this one is y equals -6. All right, so I just want you to label what the slope is of each of those lines. You can label it on the graph is fine. So just sort of look at it and see what your slopes would be. And I want 2 different volunteers to tell me what the slopes are different. Yes, Maya?
Y equals 6 is the slope of 0.
Yes, slope of 0, because rise over run, and so it goes up none over however much you feel like counting. Question or answer? Nope, you have to wait. Sorry. Okay, so this is 0. Perfect. Okay, what about the other one? All right, yes. Sorry, I got an AC in my ear. Undefined, yes, undefined. Okay, so slope is still rise over run. So look at this. Boop, boop, boop. You're going up a ton. Okay, so that would be something over, oh, there is no run. Oh, dividing by 0. That's the undefined. Okay, so this slope is the undefined slope. Notice I don't like to memorize which one's 0, which one's undefined. It comes back to how you actually calculate the slope. All right. Nice job. We are going to do 2 final examples, and then I'll give you a short break while we set up our activity. Okay, one more graph square. Okay, one more graph square. And this time, we're going to write equations. Okay, we're going to write equations. If you need more squares, guys, I've got plenty. These ones are kind of nice because they're like almost like real paper. So if you need them, I have more. Okay. Okay. Writing equations. That's EQN, equations, writing equations. And I'm going to start with y minus y1 equals mx minus x1. That's it. That's where you start. Okay? If for some reason you're like, mx plus b is like just screaming at you, go for it. Okay? But this one is more versatile because you can pick any point off the graph. Any point. It doesn't have to be the y-intercept. It's not limited. Okay? So now I actually have to get you to put some points and a slope up here. So let's go ahead and plot -4, 5. Okay? -4, 5. And 3, negative 3. Okay, so there are my 2 points. And use a straight edge because I want us to be able to tell where this y-intercept might be. Oh, okay. And then I'll zoom it in so we can see. I don't know the y-intercept. It doesn't look like an integer. And as I'm scanning this line, I don't actually see any integer coordinates that I'm certain about. So I've only got 2 points on this line here. Okay, so how do you write the equation of a line? The same way that you graph it. First, you need to pick out a point. Second, you need to pick out the slope. That's it. Pick the point, pick the slope. I suggest you use the points that are put on the graph for you and count it out. Okay, so I've got 2 points that are listed here, negative 4, 5, or I've got this one here, and my slope. Okay, 7. 8. Okay, so there's my slope. Rise over run. Now, could you do the y2 minus y1? Yes. You can also just count it on the graph. Okay. Okay, let's put it together. Doesn't matter which point you use? No. Guys, there's many different answers. Any point will do. I'm going to choose this one just because 3s are smaller than 4 and 5. That's it. That's the only reason, because maybe I like smaller numbers than bigger numbers. Okay, here we go. Y minus y1. Dump doubles. Okay, equals slope x minus x1. This is why mx plus b is not the best choice, because this does not multiply nicely. Finding the b value is not very helpful. Okay, now I am, however, going to sort of combine some of these signs here. So this is y plus 3 minus 8 over 7. And I am going to put it in y equals format. But then I'm going to leave it there. Why would I leave it there? Because it doesn't multiply out nicely. There's no reason, unless I say multiply it out. There's no reason to multiply it out. This makes it easier. Write 3, down 3. Whoop, whoop. Count the slope. Okay. I do need to tell you one other thing. It's more specifics on the forms because there's standard form is the only form we haven't mentioned here. And I just want to make sure that you are aware of it. So I'm going to flip my page because I'm at the bottom. And we're going to write standard form here. I am watching our time. We are almost at whatever that limit is for brains focusing. Okay. AX plus BY equals C. Okay, this is standard form.
Personally offended by that statement.
Examples. Okay. Okay, well, that's not standard form. It's not. That's slope-intercept form. I want you to put it in standard form. Okay, so standard form is positive A. Means the leading number needs to be positive. And no fractions. That should be like a bonus. Woo! No fractions. Okay, so this is where we come into like some PEMDAS ideas. We need to rearrange this so that it looks like this format. So first thing I want to do is put the x's and y's, like put it in order. So I'm going to add the 2/5 x to both sides. That's what I'm going to do. So we have 2/5x plus 1y. You don't really need the 1. I'm just kind of putting it there so that we can see it lining. Okay, so I'm like almost there. The problem is that the a number is a fraction right now. I don't want fractions. Part of the rules for standard form is no fractions. And so what I'm going to do, it's called clearing the fraction. Clear the fraction, which is super useful in general because nobody actually likes fractions. Okay, they're not bad, but they're not my favorite. Okay, so in order to clear the fraction, we're going to multiply by the denominator. Now, when you multiply, you're multiplying the entirety of the left side of the equation by, I'm just going to say 5/1, okay, times, right, on both sides. The reason I put the grouping symbols there is I want you to see that it's going to be distributed on the left side because it's got more than one piece there. Okay, so we get 10/5. Can I please write 2x? Yes? Plus 5y equals 15. Okay, so the first thing I did here is I looked at the order. Okay, I looked at the order. X, Y, number. I put it in the right order. X's, Y's, number. And then I looked to clear the fraction. Those are the only two things you have to consider when you're trying to get to standard form.